Okay, number 3. First, it tells us that we want the top and bottom margins of a poster to be 6 centimeters each, and the side margins are 4 centimeters each. And of course, the poster is in the shape of a rectangle in this case. And it says that the area of a printed material is fixed to be at 384 centimeters squared. We are going to find the dimensions of the poster that will give us the smallest area. So here we go. Let's go ahead and write down what we know. Draw a picture for this, of course. So let's say this is the poster, and maybe you have a person inside, be happy, dancing, or whatever. I don't know though. But I don't know the dimension either, so let's label them with, let's say, Y and X. Alright? And we do know that the inside has to be 384 for the area. Good. So based on this, we know X times Y, which is the area of the printed material inside, is 384. Now, we also want to have margins for this poster. For the top and bottom, we want to have 6 centimeters each. So go up by 6, likewise, extend this by 6 as well. So it will be like this and like that. And for each side, we want to have 4 centimeters. So extend it to be 4, and then likewise 4. So that's the picture. Alright, that's pretty much a scenario. And now, what do we want to know? We want the minimum, right? The smallest area. So the minimum of the area of the whole thing, right? The whole thing. So let's put on capital A for the area. Now, this is still rectangle, but be really careful with this. Here, on the bottom, notice here we have the X already. Right? This is also X, X. But we do have to account for the 4 and 4 for the margins. So altogether, we have X plus 4, which is X plus 8. So that will be on the bottom here. And for the side, again, pay attention to here we have the Y, and then we have the 6 here and 6 here. Altogether, we have a total of Y plus 12. Alright, so that means our area is X plus 8 times Y plus 12. Alright, once we have the constraint equation and the equation that we want to get the minimum of, then we can just do the usual steps. So right here, from the constraint equation, divide both sides by X. So we have 384 over X. And put it to here. So area will be a function of X, and that will be X plus 8 times the Y is 384 over X, which is the same as X to the negative 1, and that's put a plus 12. Now do algebra before we do calculus. So let's go ahead and FOIL this out. So we take this times that. X times X to a negative 1 is just 1, so it doesn't matter anymore. We will just have 384, and then X times 12, and then we do 8 times 384. That will give us plus 3072, and that's X to the negative 1 power. And lastly, we do 8 times 12, and that will be plus 96. And we can combine this and that together, and that will give us 480. Also, we don't really need to do that, but I'll still do it anyway. 480 plus 12x, and then plus 3072 x to the negative 1. With that being done, here we can go ahead and take our derivative. A prime of x. This will give us 0. This will give us 12. And then the last part, put the power to the front, minus 1. We will get minus 3072. and then x to the negative 2. And then same thing, go ahead, set this to be 0, and then we are going to solve for x. And to do so, I will put this to the other side and say 12 is equal to 3072 over x squared, and then just multiply x squared on both sides and all that. And perhaps I would like to just continue writing down here, I guess. Yeah, 12x squared equals 3072, and then do the usual algebra. Divide the 12 on both sides, we get 256. X squared is equal to 256. And just take the positive square root on both sides. Alright. Again, it's usually plus or minus, but in this case, the negative doesn't matter. And when you take the square root of 256, you get 16. So critical number at x equals 16. Now, let's go ahead and proceed with the second derivative test. Right here, I will get a double prime of x. And I will be looking at this. Alright, the derivative of 12 is 0, and the derivative of this, let's put the negative 2 to the front, and then minus 1 to the power. So we will get 3072 times 2, and we get positive 6144 x to the negative 3. And let's just plug in and check. You will see that a double prime of 16. This right here, again, it's extremely clear that the top is positive over the bottom is also positive. So all in all has to be positive. So same statement like earlier. The first derivative at 16 is equal to 0, and the second derivative there is positive. So we have a minimum. There is a minimum at x equals 16. Alright, we have our justification. Now y equals 384 over x, which is 384 over x is 16. And let's just go ahead and work that out. We get 24. So the answer will be, and we have to be careful, it says that we have to find the dimension of the poster. So we should also include the margin. That means we will have to do x plus 8, right? So we actually will get 24 right here, and the unit is centimeters. By the y should be added with 12. So together we will have 36 centimeters. And let me just box this. And again, let me just denote that this right here, it's because we have to do x plus 8. And that's 16 plus 8. That's how we get the 24. And for the 36, it's because of the y plus 12. And that's 24 plus 12. So that's it.